Let's talk about problem 2. X is uniform from A to B and Y equals X to the power 2. Problem A. Find and draw the probability density function of X and the distribution function of X. So we know that X is uniform function, so it is very easy that the density function equals b minus a over 1 x from A to B, and is 0 otherwise. And this plot is very easy too. It's like this. And the value is b minus a over 1. And we can count the distribution function now. The distribution of x equals we can write some part of the distribution function first. It equals 1 when x more than b, and it equals 0 when x less than a. Yeah, we can know that from the plot of density function. So for this part, we can use this function, this form. It equals a to b like this. No, this. So minus 1 equals b minus a x plus c. So we should to count this c. We know that when x equals b, the probability of x equals the value of distribution function equals 1. So when x equals b minus a over b plus c equals 1. So we know that c equals 1 minus b minus a over b. It equals b minus a over a. So the distribution function of x equals b minus a over x minus a. x from A to B. That is the final result. And this function, this distribution function's plot is like this, from A to B. So when x more than b, the value is 1. And when x less than a, the value is 0, and like this. So that is the plot of the distribution function. And problem 2, problem B. Given a equals minus 1, b equals 3. Find and draw the density function of y and the distribution function of y. And we should also count the expect of y. Because y equals x to the power 2, and x is from -1 to 3. So we can write part of the density function first. It's very clearly that the density function equals 0 when y less than 0 or y more than 9. And we can count other parts of the density function. First, when y from 0 to 1, the density function equals, we have this form. Firstly, we should to change this equation. It's like x equals this. So when y from 0 to 1, it's obviously that it has 2 roots. Don't have this part. So from -1 to 1, obviously it has 2 roots. So we should get this form. So we can get this is 4 minus over 1. And for y from 1 to 9, y from 1 to 9, obviously it has only 1 root. So the density function equals fx y direction, it equals 8 this. So we can write the density function of y. This from y from 0 to 1, and this y from 1 to 9. The density function is like this, and its plot is like this. Y, this is y. 1 and 9. When it is 1, it's 4 over 1, and this is 8 over 1. When it is 9 is 3 multiply 8 is 24 over 1. So we got the plot is like this. And it's 0. The plot is like this. Then we should to count the distribution function of y. it equals I dy, and from 0 to 1, the distribution function equals it equals plus c, and we should to make sure c1, and for y from 1 to 9, we know that the distribution function equals, it equals this. And we should to make sure of the C1 and C2. From the density function, we know that when y equals 0, the probability equals 0. So we know that the C1 equals 0. And we know that when y equals 9, the value of distribution function equals 1. So for y equals 9, so 4/3 plus C2 equals 1. C2 equals 4/1. So we can get the distribution function of y. It equals 0 when y less than 0. It equals, and this part is like this. The distribution function of y is like this, and its plot is like this: y, I, y, y. When y equals 1, the value of distribution equals 2/1, and when y equals 9, the value of distribution function equals 1. So the plot is like this, and it equals 1 when y more than 9.